All right. Good morning, everyone. In this video, I would like to discuss the solutions for our post-class quiz week 5. So let's start with the first question. You are given this sequence. AN is equal to 7n, and then we want to you are asked to write down the power series representation as well as the corresponding closed form. So because an is equal to 7n for n 0, 1, 2, and so on, then the corresponding power series representation is simply, well, this one, right? So yeah, which is, of course, we expand this form, we get this is this one. Yes. All right, so that's the power series representation. Oh, forgot the here. Yes, that's the correct one. Now that means the blanks would be filled with 0, 7, 14, 21, and 28. Now let's find the closed form of this generating function. So because gz is this summation, and this is equal to, of course, 7 z sorry, should have been the correct one. Should be 1 second. So and this is equal to this one. It is equal to, so let's, if we shift the index, we start from 1. Yeah, because the 0th term with when n is equal to 0, it is actually 0. So therefore, this is equal to 0, which is, this is n plus 1, z of n plus 1, and this is equal to 7z, this one, and this is, of course, equal to 7z divided by 1 minus z squared. Yeah, this is known, right? This one here is equal to this 1 over 1 minus z squared. Yes, so that's the answer for question 1. All right, so for question number 2, we are given a closed form of for generating functions, and we would like to obtain the first 5 terms of the corresponding sequence. So what we would do here is we first transform this into an infinite summation form, and then from there extract the first 5 terms. Let's start with the first one. The first one is GZ is 5 times 2 minus z over 1 minus 3 z squared. So one way to do it is we look at the denominator and try to get a nice form, or try to transform that denominator into a infinite summation form. So here's what we do. So this is equal to 5 times minus 2 minus z times, of course, 1 over 1 minus 3z squared, which is 5 times 2 minus z times the sum of, well, because 3z squared is the square root of 3 and z. So that is, in this case, this becomes, this becomes n. So square of 3 times z to the power of n. Let me do it again. So this is a geometric series where with square root of 3z times square root of 3 as the ratio. So in this case, this becomes here it is. Yes. So essentially, let me repeat that again. The 1 over 1 minus square root of 1 minus 3z squared correspond to an infinite geometric series with ratio 3z squared, 3 times z squared. So in this case, what we would do here is this becomes summation, infinite summation with square root of 3 times z squared, and then to the power of n. So like this, right? Now, of course, this is equal to 5 times 2 minus z, summation from n to infinity, 0 to infinity, 3 to the power of n, z to the power of n. All right. Now, what does this mean? It means that then already from here we could already simplify the form. So multiplying the summation inside, multiplying summation with 5 times 2 minus z gives us this form. uh, 10 times 2 of n z to the power of 2n minus 5z times z to the power of 2n, and this is equal to minus 5 times z to the power of 2n plus 1. So if you look at this form, you see that the left term gives us the even numbered terms. So the left term of the subtraction there give us the even number terms, whereas the right one gives us the odd number terms. So in this case, this is equal to, the left one is actually 10 plus 30 z squared plus 90 z to the power of 4 and 70 z to the power of 6 and so on. Yeah, and this is whereas the other terms you have 5z plus 5z. Oh, I forgot the 3. I'm sorry. Should have been this one. Yes. Apologize. So it should have been 5 times 3 to the power of n z to the power of 2n plus 1. So in this case, this is 15 z to the power of 3, and then this is 45 z to the power of 5 plus 135 z to the power of 7 and so on. Now from here it is easy to see that if you sum them together, you could actually get this form: 10 minus 5z plus 30z squared, because you have even powered z, so z to the power of n, where n is even on the left, and on the right you have z to the power of n, where n is odd. So you get this minus 15 z to the power of 3 plus 90 z to the power of 4 and so on. Yeah. Now that means the first 5 terms are 10 minus 5, 30 minus 15, then 90. That's part A. Now what about part B? In part B, you have gz is equal to 1 over 1 minus z square minus 1 plus 2z plus 3z square divided by c to the power of c cube, right? So now the way we do this is we could simply look at this. We try to do it this way, so let's do it this way. So we'll have this is equal to 1 over z cubed times 1 over 1 minus z square minus 1 plus 2z plus 3z square. Right? Now, this is of course equal to now this term can be changed into infinite summation. So you get something like this: sum of k from 0 to infinity, k plus 1 z to the power of k plus, sorry, the power of k. Yes. Now this, of course, is minus 1 plus 2z plus 3z squared. Now, obviously, this expression 1 plus 2z plus 3z squared are actually the first three terms of this infinite summation on the left. So essentially, this gives us sum k from 3 to infinity k plus 1 z to the power of k, right? So that's yes. Now that's our summation. Now what's left is to simply push the 1 over z cube on the left outside into inside the summation. So here, from here, we get sum of k from 3 to infinity k plus 1 z to the power of k minus 3, and this is of course equal to sum of k from 0 to infinity k plus 4 z to the power of k, and this is equal to, of course, 4 plus 5z plus 6z squared plus 7z cubed plus 8z to the power of 4 and so on. So the first 5 terms of the sequence are 4, 5, 6, 7, and 8. Yeah, that'll be it for part B. Now for part C, let's have a look. So this time we have this sum, so 5 plus 5z plus 5z squared plus 5z cubed plus z over 1 minus z squared. So let me write it down. C, you have gz equals to 5 plus 5z plus 5z squared plus 5z cubed plus z over 1 minus z squared. Let me check. Yes. Now, here, what we could do is we simply rewrite the last term of the sum into a infinite summation. So in this case, this is equal to plus z times sum of k from 0 to infinity c to 2k, because since there's this one. Yes. Yeah. Okay. So yes, in this case, this is here. From here we get that this is equal to this plus sum of k from 0 to infinity z of 2k plus 1. Yeah. Now here this is easy because then you could simply expand the infinite summation plus, of course, z plus z to the cube plus z to the power of 5 plus z to the power of 7 and so on. Now this is equal to, yeah, of course, 5 plus 6z plus 6z squared plus 6z cubed plus z of, no, sorry, there's a mistake here. Let me just do it again. So it should have been, yeah, so it should have been this. Yeah, this is 5z squared, 6z cubed plus here, yeah, c to the power of 5 plus z to the power of 7 plus and so on, right? So, and then this, that means first 5 terms of the sequence are 5, 6, 5, 6, and then of course 0. Yeah, very good. Now that's part C. That was part C. Now part D. Let me write down. It's GZ is equal to 1 over 1 plus z squared over 1 minus z squared minus, oh sorry, plus 3z over 1 minus z squared. So plus 3z, sorry, 3z over 3z over 1 minus z squared. Let's check. Yes. So what is the corresponding sequence? Sorry. Here, what we could do is we transform into infinite sum. So this is equal to 1 plus z squared times sum of k from 0 to infinity z to the power of 2k plus 3z over sum of k to infinity k plus 1 z to the power of k. So because since so k to z to 2k is 1 over minus z squared, and also a sum of k to infinity k plus 1 z to k is 1 minus z squared. Yeah. Now with that, we simply multiply the factors together, so we get this. And then this becomes right. So now we could simply expand the summation to make it more feasible. So in this case, this becomes 1 plus z squared plus z to the power of 4 plus z to the power of 6, and so on. Whereas the second term becomes 1, not 1, z plus z to the power of z cubed plus 3 plus z to the power of 5 plus z to the power of 7, and so on. And the third term is actually 3 plus 3z, I should say, 3z plus 6 z square plus 9z cube plus 12 12z to the power of 4 and then 15z to the power of 5 and so on. Yeah, of course, from here it is easy to see that this is actually simply, well, 1 plus z plus 4z plus 7z square plus 10z to the power of 10z cube plus 13z to the power of 4 plus oh, sorry, I made mistakes. It should have been, apologize. Okay, so 1 plus z squared times this summation should have been 1 with plus 2, should be plus 2 here. Yeah, sorry about that. So that means our summation becomes this one is wrong. Yeah, and this becomes z squared plus z power 4 plus z to the power 6 plus z to the power 8 plus and so on. So then this, the last summation here becomes this 1 plus 3z plus 8z squared plus 9z cubed plus 14z 4 plus 15z 5 and so on. Yeah, so that means first 5 terms of the sequence is are 1, 3, 8, 9, 14, 15, well, 14, right? So, and yes, this one. Yeah, good. So that's the answer for part D, and we'll continue next with question number 3. All right, for question number 3, we are given that sequence. So an is equal recurrence relation. An is equal to 3a n minus 1 for n greater than or equal to 1, and with initial condition a0 is 5, right? So now, first we want to determine the explicit form of the sequence. So essentially, because we know that n is equal to 3an minus 1 for n is greater than or equal to 1, then let's start with part A, right? Part A. Then the sum of n z to the power of n from n to 1 to infinity is equal to 3 sum from 1 to infinity is equal to, sorry about that, so that is equal to this summation. So 1 from to infinity, and from 1 to infinity, 3a(n minus 1 z to the power of n. Right now, from here, we could simplify this. So if we add a0 to the left, yeah, or the left hand side is equal to sum of n from 0 to infinity a(n z to the power of n minus a0, yeah, and this, and whereas the right hand side is equal to this. A(n and z of n plus 1. Yeah, and the right hand side is actually equal to z times and to 0 to infinity a(n z of n. So now we have this form. So if gz is equal to sum of n from 0 to infinity a(n z to the power of n, then we have this form, becomes gz minus a0, which is 5, is equal to z gz. All right. Yeah. So that means gz is equal to is equal to 5 over 1 minus c. Yeah. Okay. So that's, I hope I don't make mistakes. Oh, I forgot the factor, 3 factor here. So 3z, so 3z, z, so 3z is 1 minus 3z. Yeah. All right. So now with that, so this is actually answer for this is part C actually. Yeah. Answer for part C. Now, what about the power series representation? There's, so gz is equal to 5 over 1 minus 3z, and this becomes 5 over sum of n to infinity uh, 3z 3 to the power of k z to the power of k. Yeah. So that's or in other words, this is the form, right? So this is the k from 0 to infinity 5 times 3 to the power of k z to the power of k. So that means a n is actually, so this is part B, and part A is actually this. Yeah. Yeah, this is part A. Yeah, so that's the uh, solution. So it's kind of a strange because we start from C to A, but it doesn't matter in this case. All right, that's question number 3. Next, we will discuss question number 4. Now, this is question number 4. So you are given a sequence an, which is equal to the power of n plus n, and then the uh, the first part asks you to give the oh the so the question mentioned that the sequence can actually be obtained by combining two sequences, namely xn is equal to 2 to the power of n and yn, which is equal to n for all n greater than or equal to 0. Now, the first part asks you to give the first few terms of xn as well as yn. So for xn, so you have the first 5 terms are, of course, xn is the power of n, so the first 5 terms are, of course, 1, 2, 4, 8, and 16. Whereas for yn, which is equal to n, and you have the first 5 terms are, of course, z 0, 1, 2, 3, and 4. All right, so that's xn and yn. Now the next part is we create a closed form of the generating sequence of xn as well as yn. So because xn is equal to the power of n, that means the generating sequence is gx, which is the sum of n from 0 to infinity to the power of n x power of n. Yeah. Now this is equal to, of course, well, pretty easy. This is equal to 1 over 1 minus 2x. Yeah, because this is actually a geometric series, infinite geometric series, where the ratio is 2x. Yeah, so yeah, that's gx. Now for y, so yn is equal to n, and this means gy. Or let me use another term. Hy, the generating sequence is this one, infinity and y to the power of n. Now, of course, if n is 0, then the 0th term is actually 0, as we saw earlier. So this is equal to starting from 1, right? And y. Now, of course, this is equal to this. By shifting the index, you get n plus 1, y, n plus 1. And this is equal to sum of n from 0 to infinity of y n plus 1 y power of n, and this is equal to y over 1 minus y squared. So that's the generating function for yn. Now n is equal to 2 to the power of n plus n, or xn plus yn. So therefore, generating function is, say, f z is equal to the summation of gz and hz which is of course um, 1 over 1 minus 2x minus 2z plus y over 1 minus, sorry, z over 1 minus z squared. All right, now that uh, we could simplify this, so we get 1 minus z squared plus 2 times 1 minus 2z over 1 minus 2z times 1 minus z squared, and this becomes 1 minus 2z plus z squared plus 2 minus 4z, and this one becomes 1 minus 2z over 1 minus 2z plus z squared. Now this simplifies to 3. For a second, making sure nothing's wrong. So this is actually 4z squared, I should say. Did I make mistakes? Let me check. Let me go through. All right, apologies, there was a mistake here. Should have been so it should have been 2, but rather it's z actually. So yeah, so in this case, should have been, this is z times 1 minus 2z. So this gives us plus z minus 2z squared, which gives us 1 minus z minus 3z squared over 1 minus 4z plus plus 5z squared minus 2z cubed. Yeah, so this is actually, yes, it's actually the first answer. Yeah, that's sorry, do I make a mistake? Oh, it should have been here. Make silly mistakes here, but here it's fine. So the first choice of the answer. All right, so that's and the answer for question number what was it, number 4. Next, we will discuss answer or solution to question number 5. All right, for question number 5, we want to get the closed form of the generating functions of each of the given sequences. So let's start with A. Well, A is actually equal to minus 1. So the generating function gx, let me use gx, is equal to minus 1 plus 2x minus x squared plus 2x power 3 x cubed minus x power 4 plus 2 x to the power of 5, and so on. Now, this could be separated into two parts. So the the odd terms and the even terms. So this is yeah, and plus 2x plus 2x 3 x multiplied plus 1. Now, this left part is actually minus sum of x to the power of k, x to the power of 2k, I should say, where k is from 0 to infinity. And then this the other one is sum of 2x k plus 1, k from 0 to infinity. So you should say 2k plus 1. Yeah. Now, this is equal to minus 1 over 1 minus x square, and this left part is 2x times sum of k from 0 to infinity x to k. Yeah, which is of course 1 over 1 minus x square plus 2x over 1 minus x square, and this gives us a solution 2x minus 1 over 1 minus x square. Yeah, so that's gx for part A. Now what about part B? In part B, gx is the generating function. Gx is actually, well, 2x plus 6 x squared plus 6x cubed plus 2x power 4, and that's it. Now this is same as, of course, 2 times x plus let me again. So this is actually equal to 2x times 1 plus 3x plus 3x squared plus x cubed. So now the one within inside the parentheses is a form of binomial expansion. So this is equal to, of course, 2x and sum of k from 0 to 3 k, sorry, 3k, you know, a combination of k from 3 x to the power of k. Now the summation is, by binomial theorem, is equal to 2x times 1 plus x cubed. All right, so that's the closed form. Now what about the next part? C. Part C, gx is 1531. So 15 plus 31x plus 63x squared plus 127x to the power of 3, and then 255x to the power of 4, and so on. Yeah, so this is 15 is 2 to the power of 4 minus 1. 31 is 2 to the power of 5 minus 1. 63 is 2 to the power of 6 minus 1. And then 127 is 2 to the power of 7 minus 1 cube. 255 is 2 to the power of 8 minus 1 x power of 4 and so on. So we could simplify this into a summation. So this is essentially from n from 0 to infinity. The first term is 2 to the power of n plus 4 minus 1 x power of n. Yeah, so that's how we get the form, and now we simplify this, so we get this is equal to of course simply multiply them. This becomes n to infinity 2 power n plus 4x to n minus sum of n to infinity x power of n. Now, of course, this becomes um, 16 sum n 0 to infinity 2 power of n x power of n minus sum n from 0 to infinity x power of n. Now, the first summation here allows us to simplify, so we get this 1 minus 2x, yeah, 16 over 1 minus x, and this one is of course 1 over 1 minus x. Now you could simplify further, for example, combining the operating the subtraction to get 16 minus 16x plus 2x minus 1 over, of course, 1 minus 2x times 1 minus x, and this gives us 15 minus 14x over 1 minus 3x plus 2x squared. So this is form, right? So that's part C. Now part D is this one. So let's see. The sequence is minus 2. Sorry, 2. Let me start. So it's minus 2, 4, 0, minus 2, 4, 0, and then 4, 5, 6, 7. Okay, so 5, 6, 7, right? So we could write down this into two parts. So essentially, this is the first part, and this is the one. So essentially, this becomes minus 2 plus 4x. This is one part, plus 4x to the power of 4x cubed plus 5x of 4 plus 6x to the power of 5 plus, so this is gx, all right? So gx, yeah, 7x to the power of 6 and so on. Now, so gx then becomes minus 2 plus 4x plus sum of n from 0 to n from 3 to infinity, yeah, 3 to infinity, n plus 1 x to the power of n. Yeah. Now, of course, the one on the right. So we could simplify this further. This is minus 2 plus 4x plus sum from 0 to infinity n plus 1 x square of n minus, of course, 1 plus 2x plus 3x squared. Yeah. So this gives us a very nice form. So we have uh, uh, operating the summation. So we have minus 3 plus 6x minus 3x squared plus, now the infinite summation becomes 1 over 1 minus x squared. Uh, and this is actually minus 3 times 1 plus 2x plus minus 2x, sorry, minus 2x plus x squared plus x squared, and this is minus 3 minus 1 minus x squared plus 1 over 1 minus x squared. Now, of course, simple algebra manipulation gives us that minus 3 times 1 minus x to our cube plus 1 over 1 minus x square, and this is, of course, this, and finally this is equal to minus 2 minus 3x plus minus 6x, sorry, not minus 6x, so yeah, minus 2 plus 9x minus 9x squared plus 3x cubed over 1 minus 2x plus x squared. So that's the closed form of the solution. So for part D. So this concludes solution question number 5, and also the end of quiz, post-class quiz week 5. All right, thank you.